If you've ever had to take a precise measurement from the diameter of a hole to the thickness of a material, or the diameter of a rod, you know you wouldn't be able to make that measurement accurately with a ruler. And for certain types of measurements, we need a device that gives us precision beyond just millimeters. Today I'm going to tell you what a caliper is and why you should have one of these at home. Have you ever stopped to think about how the world around you manages to fit together so perfectly? From the screw that holds your phone screen in place to the complex parts of an airplane engine, if we try to measure these things with a regular school ruler, we would certainly fail, because human vision has a limit of perception that prevents us from distinguishing very small fractions of a millimeter. But what if I told you there's a tool that can transform your perception of size, allowing you to see and measure distances 10, 20, and even 100 times smaller than the smallest mark on a conventional ruler? This instrument is the caliper, a fundamental tool in metrology. Even though it might seem intimidating at first glance, it's one of the most versatile allies you can have in your toolbox. But what exactly is a caliper, and why does it have such a peculiar name? The term pachymetro has its roots in Greek, coming from pachymetron, where pachys means thick or broad and metron means measure. In a literal translation, we would be talking about a thickness gauge. Although rudimentary contact measuring instruments have been found in Greek and Roman shipwrecks dating back more than 2,000 years, and the records show that the Chinese were already using similar tools during the Han Dynasty. The caliper, as we know it today, is the result of a brilliant mathematical development that took place in the 17th century. Before that, measuring something accurately was an immense logistical challenge, because we relied purely on the operator's visual acuity to estimate where one mark ended and another began. It was against this backdrop of the need for precision that a central figure in the history of science emerged. Can you imagine how difficult it was to manufacture interchangeable parts without a strict measurement standard? In 1631, the French mathematician Pierre Vernier published in Brussels the description of an invention that would forever change engineering, the Vernier scale, also known worldwide as the Vernier scale. Vernier did not invent the concept of measuring by contact, but he created a logical system that allowed a unit of measurement to be subdivided into much smaller parts, without the need for microscopes. He realized that by overlaying two scales with slightly different divisions, the human eye could easily identify which line from one scale aligned perfectly with the line from the other. This innovation allowed craftsmen and scientists of the time to measure to tenths of a millimeter with complete confidence. But how exactly does this mathematical logic from almost 400 years ago translate into the mechanical operation of a modern tool? To understand how a caliper works, we need to look at its anatomy, which is a perfect example of functional design. It consists of a fixed graduated ruler and a movable slider that slides over it. The secret of precision lies in the interaction between the main scale and the Vernier scale on the slider. When we close the caliper, the zero on the fixed scale coincides with the zero on the Vernier scale. When we open the tool to measure an object, the zero on the Vernier scale moves, indicating the whole measurement in millimeters. However, rarely will an object have exactly a whole number in millimeters. This is where the magic happens. We look at the Vernier, for which of its subsequent marks aligns perfectly with any mark on the fixed scale. If the third mark on the nonius is the only one aligned, we know we have an additional 3/10 of a millimeter. But why is this visual coincidence so much more precise than just eyeballing the value? The explanation lies in the difference in spacing. In a regular caliper with a resolution of 0.05 millimeters, the Vernier scale has 20 divisions that take up the space of 19 millimeters on the fixed scale. This means that each division of the Vernier scale is exactly 0.05 millimeters smaller than the division of the main scale. When you move the cursor, this tiny difference keeps accumulating until two of the marks line up. It's a system for visually amplifying positional error. Nowadays, this analog reading, although extremely reliable and independent, requires a bit of training and good eyesight. That's why digital models have become so popular. By using capacitive sensors that translate the movement of the cursor directly into numbers on a liquid crystal display, the digital caliper eliminates any doubt in reading and speeds up the work process. In addition to the scale, the caliper is designed to perform 4 different types of measurements in a single tool. We have the larger jaws for external measurements, such as the diameter of a tube or the thickness of a part. At the top, we find the inside jaws for internal measurements, ideal for determining the diameter of a hole or the width of a box. At the end, opposite to the jaws, there is a depth rod that extends as we open the slider, allowing us to measure the depth of blind holes or cavities. Finally, the back face of the caliper itself can be used to measure shoulders or steps. This versatility is what makes it superior to any other simple measuring instrument. But where in our daily lives does all this precision really make a difference for someone who isn't a professional engineer? The usefulness at home becomes evident the moment you decide to fix something instead of throwing it away. Imagine that the support wheel of your curtain broke, or that the knob on your stove cracked. To buy a replacement part, or even to adapt something you already have, the difference between 12 millimeters and 12.5 millimeters is the difference between working or the part being loose and falling off. In my case, the caliper has become an extension of my hand since I started working with 3D printing. When you design a part on the computer to be printed, you need it to fit perfectly with real-world objects. If I want to make a part with gears, pins, and moving pieces, I need to measure the width, height, and position of each one with an accuracy of tenths of a millimeter. This wonky engine that I printed, all the work started with modeling the parts and defining the necessary clearances. No matter how precise a print can be, there might be some expansion of the model, and what was supposed to be 35 millimeters could end up being 35.15 millimeters. And as the parts are being printed, adjustments need to be made. Without a caliper, I would spend hours on trial and error, wasting filament and time. And with it, I could simply adjust the next piece according to the printed part. But is this tool only useful for those who have high-tech equipment at home? Actually, the caliper is the best friend of do-it-yourselfers at any level. If you enjoy woodworking as a hobby, you know that measuring the actual thickness of a piece of wood, which is rarely what's written on the store label, is crucial for making perfect joints. For home repairs, it helps you identify the exact diameter of a drill bit that's lost its marking, or measure the diameter of a screw you need to replace. Having a digital caliper on hand makes these moments much easier, since you can switch between millimeters and inches with the touch of a button, which is a real lifesaver when you're dealing with international screw standards. For those of you who want to have this very versatile tool at hand, I'll leave several options for calipers in YouTube Shopping and also in the first link in the video description. I have two types of manual calipers, one made of plastic and the other made of steel, which I used for a long time. And now I have a digital caliper, and it's really worth having one. There's another type of caliper as well, which is the dial caliper, which is another model, but it has the same function. But tell me, how do you usually solve the problem when you need to buy a screw identical to the one you've already lost? The precision that the caliper offers gives you peace of mind. When you measure something and get a value like 15.45, you stop working with assumptions and start working with data. This prevents unnecessary trips to the hardware store and ensures that your personal projects have a professional finish. Even if you don't use the tool every day, the value it adds when you need it is immense. It's the kind of instrument that once you learn how to use it and realize how easy it is to read the modern models, you wonder how you managed to live so long using only a tape measure or a plastic ruler. But do you know how to take a proper measurement to ensure those numbers are accurate? Taking a measurement with a caliper seems simple, but it requires technique to avoid common mistakes that can compromise the result. The first step is always cleaning. Any grain of dust or trace of oil on the measuring jaws can add false hundredths of a millimeter to your reading. Before you start, gently close the caliper and check if it reads exactly 0. On digital models, this is done by pressing the 0 button with the jaws closed. For an external measurement, you should position the object as close as possible to the main scale, avoiding using only the tips of the jaws, which are more susceptible to deformations or misalignments. Apply firm but gentle pressure. That's because squeezing the object's material too much results in a measurement smaller than the actual one. A factor that often isn't taken much into consideration is temperature. That's because the object's temperature can also influence the measurement due to thermal expansion. For internal measurements, you need to be even more careful. When inserting the upper jaws into the hole, make sure they are perfectly parallel to the opening. Ideally, you should open the caliper until you feel contact and give it a slight wiggle to find the point of greatest opening, which represents the actual diameter. To measure the depth, the rod must be kept perpendicular to the base of the hole. A common mistake is tilting the caliper, which creates a hypotenuse and causes the measured depth to be greater than the actual one. After obtaining the measurement, it's important to interpret it. On the analog caliper, you read the whole millimeters on the fixed scale before the 0 of the vernier, and then add the fraction where the lines coincide. On the digital one, the hard work is already done. You just need to read the number on the display. Regardless of the model, practice makes perfect. Start by measuring objects of no size, like coins or new screws, to gain confidence in your reading and the pressure you apply to the slider. Over time, you develop a tactile sensitivity that will allow for consistent measurements. If you've made it this far and enjoyed the video, take a moment to subscribe if you haven't already, leave a like and turn on the notification bell. And if you find our content interesting, consider becoming a member to help us keep producing content here on the platform and to be mentioned in our videos. And if you're curious to learn more about the courses we recommend, scan the QR code here on the side or check the link in the video description. To have access to various opportunities to develop several skills that will make a difference in your career. And what about you? When was the last time you needed to measure something precisely and a regular ruler let you down? Have you ever used a digital caliper and noticed how much easier it makes things compared to the traditional model? Leave your comment below, sharing your experiences or questions. I want to hear from you. On the side here, there are 2 interesting videos you should watch to expand your knowledge and satisfy your curiosity. Want to support us? Just hit the like button, subscribe to the channel, tap the bell, and consider becoming a channel member. That's it, engineering lovers! Sending you a big hug, and I'll see you in the next video.